Welcome to lesson 7, and these lessons focus on the application of data science in Python, specifically data science tools that you can use in Python. And the first one we're looking at is Numpy. And these notes were developed in collaboration with Andrew Gill and myself, Benjamin Bosch. So this is a quite important part of Python and this course, because this looks at application of Python, how to use it, especially for your research. So why use NumPy? Well, ordinary Python can do quite a bit out of the box. The list data structure is very powerful, much more flexible than a C or Fortran array. If you know about C or Fortran, they're very popular, yet old languages, but very fast. So built-in math libraries contain like mathematical functions, even for complex numbers. What more could you want for this? Well, NumPy is built to make it easy to handle numerical data and to do calculations for scientific applications a lot quicker as well. So the core of NumPy is a NumPy array, which an array is similar to a list, and adds a huge amount of functionality, which makes sense for large data structures or which has numerical data. So coupled with this, NumPy allows for efficient matrix arithmetic, which includes a lot of efficiently implemented linear algebra, matrix manipulations, and so on. For example, inverting matrices, finding eigenvalues, determining, transposing a matrix, all these features. So all of these would be quite complicated to do by hand, so to speak, with the ordinary Python functions. So that's why NumPy allows us to do these a lot easier. And then also, one-line functions for reading data on various formats like spreadsheets or binary formats. So the basics of NumPy, how do we use NumPy? Well, it's pretty straightforward, like we've done before. In the previous lesson, we discussed modules, libraries, and functions. We have to import it using a simple command called import NumPy as MP. It is built in it is built into Python if you install it via Anaconda. If not, you would have to install it manually. So if you say import NumPy as NumPy, you should be able to use it. Now, you already use the range function a lot, as we've done with like for loops and lists, and it's very useful, but it only works with integers. However, in NumPy, there's a function called arrange, which is array range, which can take arbitrary floating point increments. Right? So let's try this out and see what this looks like. So let's copy this line over here and go to file, let's import that, and let's open up, copy this as well over here, and go to our code and paste it, save and run it, and see what you get. Cool, so we get an array, which is like a list that increments from -0.1 to 0.5 in steps of 0.07. Okay, so there we get the output. So remember, in the previous lesson, we also spoke about the method and function has a dot before it. So this is what we're speaking about. So this is actually a method, or you can call it function as well. But you can see all functions we'll be referring to here are better known as methods, because they form part of a library. So to keep things simple, we'll be calling them functions. Now there's a similar function called linspace. If you know about linspace, which instead of using a step size as a parameter, instead you can specify the steps that you want to use. So we can do a similar thing. We can just copy this and go to your file and print that out. Maybe let's call it Y instead of X. Let's put it over there and run it, and you can get something similar. So it's just a different way of defining a set range of values. So also note that this includes both the starting point and the endpoint 100, unlike a range and a range. If you use MATLAB or Octave, this may be similar to you. We also have other features like eigenvalue, ones matrixes, zero matrix, which would behave as expected. You get an eigenvalue array, and ones and zeros. You'll see what you get if you print this out. And the cool thing is NumPy arrays are compatible with lists, and it's quite easy to convert. So if you just maybe copy this out over here and paste, let's undo that. Let's paste that and print AA. We should get 1, 2, 3. So you can easily convert to this. So we know this is a list with that. All right, so let's move on. So you can also do 2D arrays by giving a list of lists, as we've shown before. We've done grouping of lists, and we can change it as well. So you can try that out for you. We can find the inverse of an array called BB. You can do that by you doing the following. Do that over here. I think you first have to print that out. You don't know what BB is. Maybe I haven't used BB, so let's first, I actually need to do this. Copy BB, put it there, and then I actually have to just print it out because I wasn't going to do anything. So let's print it out, see what I get. Okay, I get 29. So that is fine, and then you can first check if it's possible to find the inverse by working on the determinant. So it is, and then we can just go back here and work out the inverse. So quite straightforward steps. Notice the determinant inverse are part of NumPy, the linalg module, which is a submodule within NumPy dealing with linear algebra functions. There are some more simple matrix operations like multiplication using dot product, also based on NumPy. For example, we can find the dot product between BB and its inverse. So let's try that out too. Well, I mean, you'll see what the output is, but this is the command for that, which will give an identity matrix, which is one of the diagonals and zeros or very small numbers. So this is if you need to do this kind of thing. So it goes into quite a bit of detail. You can go through that. There's arithmetic, NumPy arithmetic as well. We can add and subtract arrays together. But just note that all arrays have to be the same size and shape, and you can check that just using the size and shape methods over there. So you can just read that out. So you can read this if you really need to do matrix arithmetic. You can go through all this. So an important thing as well is that the NumPy function reshape allows you to rearrange arrays so the elements are arranged in however many rows and columns you want, as long as the rows multiplied by the columns stays equal to the total number of elements, right? So this is really if you need to do multiplication or if array arithmetic. So these are different applications you can use. So a 2D array can also be transposed with the .t of the variable name. You can transpose an array quite easily. Also importantly, with arithmetic multiplication and division, do element-wise multiplication and division. Again, only if the shape of the matrices are appropriate, they must have the same number of columns of at least, right? So this is really useful. This is really useful to do element-wise multiplication. which is compared with this with a non-mathematical way in which plus, minus, and multiplication operate in Python lists. So make sure you don't confuse between the two. Okay, so some unique features. NumPy has its own math functions. You can use math functions. So maybe let's, this is just creating a sine wave with the parabolic, I think. So let's just copy this code and see what happens if we get that. I don't need this anymore. I should just delete it. That anymore. I think it's complaining because of the comment. Yeah, this is a comment. Save and run it. And yeah, so it just prints out sinusoidal in a exponential graph. Okay, so that you see over there. So to do this, it would have been quite tricky with a for loop to the same thing we did with NumPy arrays and the SYN methods. Either way, you have to use a lot more lines if you just use conventional Python. So again, if you want to do curve fitting, you can use polyfit and polyval. So there's an example of that. So really useful applications that you can use in NumPy if you need to do this. You can also use random numbers. There's various options to generate random values. And you can also calculate the sum, mean, and other stats from arbitrary array, similar to with lists, but lists you don't have all these features. There are other useful tricks with NumPy. You can check if values are alike or same or not using just a greater than, smaller than symbol, which is quite handy sometimes. Reading in CSV files. So if you have data, so let's maybe try this out. So let's just copy this to a file. Let's try this one out. So let's just paste it and let's call it my data.csv. Save it as a CSV file. And then we're going to read it to a NumPy array, and all we do is we're going to skip the first row and the delimiter, or how it's separated as a comma, because obviously a CSV file will separate it with a comma. So I'm going to go back here. So that's our file, and then we're just going to say, I think it's called my data.csv. That's it, and I can run it, and then you should, yeah, there we go. So that's all the data, same data that we have there. We have access to now, and can manipulate or analyze however we want. So as you expect, load text is a friend called save text. You can save the data after you change it or around however you want. Sometimes you have dirty data, there's gaps in between, or so then it's better to do something called gen from text, which is something I would recommend as well. Let's rather use gen from text. This gives you a lot more options if you are playing around with the data. So I don't need that. So let's call my data. So if I run that, yeah. So there I can filter the data a little bit more. So each of the column names I can filter into these NumPy arrays, and I can put it out. I can also skip the header if I want to, and I can play around with certain features of it. So what does this gen from text do? Voltage.csv, this is the name of the file. Unpack true is just to return the transpose of the array. This is just how it's read through. Delimiter versus the type of delimiter used to separate data in a file. So it's a CSV, so use comma. Skip headers, first number of rows, and skip from the top of the file. If even that is enough, you can use pandas, which is actually what I would recommend. But we're just showing you all the tools of NumPy for the time being. Linear regression. So this is a nice application. Anytime you type of any statistics or data science, you'll run into linear regression as an important tool to understand how to fit a straight line to data to see the trends of it, right? So I'm just going to copy and paste this data as is, and let's just see what you're going to get out over here. So let's just copy and paste this over here. Okay, so this is the data. We haven't fit the straight line to it. Again, just copy and paste how the plotting works. You don't have to worry about that just yet. We will get into that. So that's the data. So let's do a linear trend to see if there's a relationship between that. And you can read through this, but this how do we define the data? What is X and what is Y? Input variable versus output variable. These are all things that you have to get used to. And the purpose of finding fitting a line is working out the slope and regression coefficient. So we can do that easily with built-in functions called poly-d, and to find the predicted future result, for example. So I can work out a model for that, plug in a certain value, and you get that out. So you can read through this and see the results that you get. Also, to work out the accuracy of a model, you would use the R-squared value. So there are built-in ways to work out R-squared value, not so much in Numpy actually, but in a library called sklearn. But to do that, I actually did this by hand because I think it's quite interesting. If you just follow this equation, you can work it out. So I'm going to copy and paste this as is because that's actually quite a nice way to work out the variance. We'll work out the variance. So I'm going to copy and paste that. Okay, that one. Let's see, I run it. I can work out the variance for this data set that we had 0.87. So as you know, closer to 1 it is, the more you can see a trend in the data. So it's good enough to fit a linear line. You can actually do if you use a sklearn library, which is one of the machine learning libraries, you can actually do a one-liner to work out what the R2 score, R-squared score is. And you can figure out what that is. Lastly, I think this is just all the code together, just to show you what it looks like. And let's just plot that and see what you get. ACC model. Where is ACC model? That should be okay. We don't actually need that. We don't actually need that, so we can just do that, and then you get there. We go. So there for the straight line, and that shows the equation as well for the straight line. So it's, you can see it's quite a the data is quite linear. And there's results. So yeah, so there's a lot of NumPy that you can work through. This is just a brief summary. So we'll move on to the next lesson.